Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth.
Hello, folks. Today we are joined by Jesaitis and Stephen Colenzo to discuss hackers, the space domain, and the event that brings both together, Hackasat.
In 3, 2, 1.
Steve and Delia, we're really excited to have you here today.
Thanks. We're excited to be here.
Yeah, thanks for having us.
Yeah, I know that most of your day is spent now working with hackers or planning to work with hackers. So,
A quick question before you go ahead. You said hackers. Are we talking like the classic movie from the 80s, Tron, where people are being zapped into computers using identity disks and chucking them at each other? Like, is that the kind of hacking we're talking about, or is this something different?
It's actually a little reverse, but it's similar.
Hey.
Because what we're working with is space and satellites, and using that infrastructure kind of puts us in this alternate reality that allows us to be more efficient and get from point A to point B and make cell phone calls. So if you take your analogy and you reverse it, we're not actually in software, but software does allow us to do what we're so very capable of doing in today's age, I should say.
So to make sure I heard that right, when you say I'm in, they literally mean that. You guys are in whatever that system may be.
Yeah, you got it.
well, to jump back in a little bit. So, Steve Colenzo, Delia Jesaitis, you're both part of our tech transfer team, or you have been in different roles throughout your careers with AFRL. And you've been very involved in Department of the Air Force's Hackasat kind of event and campaign. Can you tell us what is Hackasat?
Sure. Along with the tech transfer nature of things, which is really about the government getting its technology and our software out to the public, Hackasat is part of that. It's very much as you said, campaign. It's a very much a public event in which we challenge the world's best security researchers, hackers, to take on challenges that are related to space systems. And the whole idea behind that is taking the knowledge and understanding how you look at problems from a different perspective, not necessarily from a malicious perspective, but different than from a design and development. I'm making a satellite for a certain purpose versus, let's say, hack the satellite and make it do other things to serve other purposes. Understanding that for the globe is really important, so then we can feed that back into all different countries' systems, as well as the way we operate things, so that we can be more safe and secure. So as I alluded to, our daily lives are intertwined and entangled with space systems, and making them safer and resilient for the globe just helps everyone. It's that whole rising tide raises all boats type mentality.
I think just to add to that, the evolution of satellites, satellites were designed for survivability, and essentially they weren't designed with security in mind up front. They were designed to make sure you can communicate with them and they are operating and fully functioning. Satellite operators' worst fear is that they can't communicate with their satellites. So they've, historically been designed with functionality and survivability in mind. And as we evolve as a society and become more and more dependent on them, we have to start putting security in the front of our minds when thinking about the design as well, because we leverage satellites for so much of the way we live in this modern world. So that was another really important reason why we had to bring some attention to this subject.
Absolutely, Delia. When you say our way of life is really centered around satellites and things in space, it makes sense to us why the Air Force and the Space Force are so interested in securing space. Our GPS, financial transactions, air traffic control really depends on whatever space systems are out there. And if they're vulnerable to attack, then that creates a problem. And I didn't realize that people really weren't thinking about that when back in the day when they're just trying to get this technology up there to accomplish a mission, not that someday someone more at the everyday level could hack it or interfere with these technologies up in space.
When we were starting sort of our communications plan around this event, we analyzed this similar to the way the internet started. So when the internet started, it was this small network of computers pushing packets of information to one another. And it wasn't designed with security in mind. It was designed to just literally, can I send this message to this other machine? As it evolved and it eventually commercialized, similar to how space is commercializing significantly at this point, as we now see the internet, security is constantly being reminded. We're constantly being reminded of the uh, concerns with security on the internet. And we don't want that to be what our dependency on outer space looks like in the near future, as this entire domain commercializes and it becomes much more accessible for commercial entities. So it's kind of similar to the internet in that way, and we're trying to get ahead of it because we were early founders in the infrastructure and development of satellites in outer space.
That is really fascinating. It's something cool, though. As a historian here myself, a minor historian, I love talking about internet history and a lot of things that led to what we have today. And you mentioned something earlier, Delia and Steve, about this idea of disruption. The communications can be disrupted with satellites, and there's a lot of things up above our heads in the space domain that can be threatened by, as Michelle said, everyday folks, it seems like. So it seems very counterintuitive to some that we'd go to hackers for help. So can you go into why they're such an integral part of this mission and how you even approach that? I would not think the hacker community would be like, hey, wait a minute, I think the U.S. Air Force is asking us to do some help. How did that kind of play out?
If you take a step back and you look at, you mentioned Tron, and that was like programmers getting stuck in software and they having to figure it out roughly, loosely figure out a way to get out. And whenever we approach technology as just a human, it's usually to help us do something. So we're making a piece of software, we're making a piece of hardware, we're making the two of them together, a system, if you will, to do something, and maybe to help us do something easier or something that we can't do ourselves. And when you're constantly looking at it through that lens of trying to make the software or the system or the hardware do something, you oftentimes forget about the flaws or vulnerabilities, if you will, that you may inherently write into the code or put a circuit in the wrong spot that allows it to do something else or affect something else. And when you look at the word hacker or security researcher, I pair it with ingenuity and curiosity, because those two traits are what allow you to take a look at something a little differently and try to make the thing do something else than it was originally intended for. So that's why we decided to look at this DEF CON community. DEF CON is a security conference, as we like to call it, that's been around about 30 years this coming August. And all of the individuals that show up there are curious, ingenious, and they just want to learn. And space is really hard to learn. So that's where those two come in. It's like, you don't just go and start learning orbital dynamics, orbital physics, astrophysics, but you can. And if you have the willpower and enough curiosity, you might just find the intersection of the space world and the cyber world, as we call it, with a lot of things open to do and to affect change both in the positive and the negative way.
There's this negative connotation. I think you might have mentioned that. This community very grassroots, and DEF CON is not a conference where you go and you set up a booth and you're selling your product and there's all sorts of logos. It's all about education and workshop and hands-on and really just tinkering this with different types of technologies and things that were designed various ways to see if they can make it do something different or learn how to build it themselves. There's a lot of soldering at DEF CON. So it's this very educationally focused community gathering, essentially, that is blown up into this tens of thousands of people who come together to work on this stuff. And it's their hobby. It's what they do for fun. I mean, it's also what they do in their careers in some cases. But what better place to go and say, hey, mess with this technology. Tell me if you can get into it. I designed it and I thought I designed it really nicely, but you've never seen it before. Tell me what you can do with it. And it turns out like Jeep brought their Jeep and somebody was able to hack into the Jeep and drive it remotely. And obviously the companies that bring their technologies to DEF CON, they do it so that the hackers can inform them on how to better secure their systems. Here are where your vulnerabilities lie. So it's all in with good intentions in mind. I mean, so we go into this thinking that way. We're not like trying to embrace anybody with bad intentions to do bad things. It's really, hey, teach us what we're not paying attention to us as an organization.
I would say the word meritocracy comes to mind, where anyone with skill and imagination can aspire to reach the highest level if you provide an avenue for that. And that's what we did with Hackasat. And that avenue was space relevant systems that were really challenging, and then merging and weaving in the cyber aspect of things, which you would expect to be reverse engineering, scripting, encryption, things of that nature. Because space systems are intertwined and cyber intertwined with one another anyways, but they usually are seen as decoupled when you're looking at it through the lens of, well, I need to learn this new area of physics to understand orbits and whatnot, versus I have to understand how to reverse engineer something. So bringing those two disciplines together is really what we aspired to do with Hackasat. If it would be enough to do Hackasat just because of the dependency of the world on space systems, but also, and Delia sort of alluded to it, the democratization of space with all these new companies forming. Hackasat is a message to those new companies that they need to care about cyber hygiene, because we, the government, or another company or other governments will be consumers of those products. And if we're all just at the beginning of the internet here, we're going to end up like the internet is now, which is you really got to tread lightly when you go to a various website, and you got to make sure you have certain protections in place on your computer before you go ahead and do something that may be you might be skeptical about doing it. So those two things were really the big thrusts for Hackasat.
And I'd like to take that a step further and start through what was Hackasat 1, the first year's first challenge. How did you work alongside hackers to not only pull them in, but make this such a successful event?
So Steve, I'll let you talk a little bit about the competition, and then I'll be happy to kind of touch on how we developed the relationship with this community. It's not something you do overnight. You really have to be mindful and genuine in developing an authentic relationship with the hacker community, because you don't want to be seen as, clickbait marketing or any of that kind of stuff. We want to be transparent about the fact that this is a global challenge and everyone around the world cares about resolving it. And the only way we're going to do it is if we pull together as a community. And so we developed a marketing campaign to really meet the community where they are. So we didn't go after them with big Air Force branding and marketing. And we developed a Twitter handle, and we just started producing content that was relevant to satellite security. We started telling them, here's what you need to study. Here's who you need to have on your team. This is various articles that are relevant in the trades, giving them meaningful content online, producing podcasts, all these different ways to really meet them authentically where they are, and rather than expecting them to find us and dig the material up from us. So with that, we were able to develop and start fostering community and communication online during the middle of the pandemic. I mean, we kicked off like right when COVID hit in 2020. But with that, Steve, I'll let you talk a little bit about what we did with Hackasat 1, because we did have to pivot fully to virtual. We had originally thought we were going to be in person, but it became a fully virtual event.
Okay, so for Hackasat 1, we really tried to do is we came up with the idea of, hey, we're going to have a capture the flag challenge. And the capture the flag challenge is essentially a competition where you're faced with challenges, and the solutions to those challenges are considered as flags. And once you find the solution, the flag, you submit it and you get points. But to do that on a large scale virtually, while it's commonplace, in the space world, it was just a little bit different to figure out what are the challenges going to be that aren't too hard for anyone to tackle, but then not super easy, that it's just kind of a wash, and it wasn't relevant to the space world. We found out that in and of itself was pretty difficult. So Hackasat 1, Hackasat 2, and now Hackasat 3, they all have the same format, where there's a qualification event that happens online over a 30-hour period on the weekend. And we came up with categories of challenges that were cyber, some were cyber related. And when I say cyber, they're more computer related 100% versus physics in space. So reverse engineering, scripting challenges, those are your typical cyber challenges, but then also various things about orbits and sensors and being able to compute various things like a quaternion. And the qualification event is meant to select the top 8 teams that go on to the final event. And the final event is your capture the flag challenge. So the qualification event is just solving the challenges, amassing the most amount of points, gets you a ticket into the final, which we call the capture the flag challenge. And that the first year was done on what we call a flat sat, which is historically a flat version of a satellite that's in outer space, laid out on a number of different tables, depending upon the size of the satellite, where you can test things out on it first before ever going to the actual satellite up in orbit. So we had these CubeSats that each team would remote into, because as Delia said, we were virtual, everyone's globally dispersed, COVID, and the Hackasat CTF was more serial in nature, where the top 8 teams just faced the challenge. They didn't bother with the infrastructure, trying to mess with it or do anything nefarious, and they didn't bother with other teams. They were just head down, here's your challenge. First team to solve the challenge gets the most points, and then it's on a decaying point scale after that, to the point where if teams weren't getting it, we give you the solution, move on to the next challenge. And in that, the team with the most points wins. We had a specific unique challenge in Hackasat 1 that we called the on-orbit component. So we worked with some of our Space Force colleagues, and the teams that were competing had to come up with an operations plan to rotate a satellite that was actually in outer space to take a picture of the moon. And they had a time frame to do that, and it was a must compete. It was a pass fail. So if you didn't submit a plan, you couldn't win the competition per se. And a lot of the teams came up with some really unique plans to turn this, or rotate, I should say, this satellite to take a picture of the moon, which it wasn't really ever intended to do. It was a satellite to take pictures of the Earth. So it was really unique, and it was the first taste of, wow, this is pretty hard to do this actual maneuver in a timely manner. Also conserving power, and there was some other different characteristics in it. But loosely, qualification event followed by a final event. And that's what we did for Hackasat 2. Hackasat 2 was just a little bit different because the final event also had flat sats, but they were a little more robust than Hackasat 1. They had some other different unique things. And the additional complexity that we threw into the CTF, the Capture the Flag Challenge, was the fact that teams were required to defend themselves from attack and to attack other teams' satellites. We had software-defined radios that gave a piece of a spectrum to talk to the satellite, so the teams could talk to the satellites over radio frequency, as well as a hardwire connection. But again, they were disparate locations across the globe. So we kind of like took that model from Hackasat 1, Hackasat 2, and then we're continuing that for 3. But loosely, that's what the challenge looked like. So your qualification event, it's no small feat to develop all those challenges, stand up an environment for 30 hours. That we had 6,000 participants in Hackasat 1 qualification event, which was roughly 3,000 teams. And then Hackasat 2, what we found is we had less teams and people participate in Hackasat 2, but more of the teams scored points. So less people, but better skill set for teams accomplishing those challenges. And then for Hackasat 3, we're going to do the same thing. We're going to have a qualification event and then ultimately a final event.
And before diving fully into Hackasat 3, I'd love to get some idea here, kind of going into what you described with Hackasat 1 and 2, with these separate teams around the world, which first of all is so cool that we can bring in really anybody. That's so neat. So when people were actually doing this, were they actually doing, so we I assume made a virtual construction of a satellite, or at least software data they were able to work with, and you said eventually hardwire to, or at least connect with. Was there a monitor who was actually with them? Was there a server that we were all hosting that they were able to go through? Like, how is this all being run with people everywhere?
In and of itself was a tall order. But as I mentioned, those flat sats, those satellites, those flat sats were on a network that the teams would connect into the network, and then ultimately their actual system, which had a number of pieces of software running on it, as well as specific hardware. And we released all the software and all the specs after each event. We released that on our Keep Learning page at hackasat.com. That's another portion of that tech transfer that we let off this podcast with, which is giving back to the community. So we're not just taking everything, we're developing it, hosting it, allowing a competition to happen on it, also handing out monetary awards, and then giving all the data and everything to the community so that they can recreate it themselves if they wish and continue to learn and refine and hone their skills.
There was one nuanced detail. So in Hackasat 1, we expected to be in person at DEF CON. We had a whole floor space planned out, and the teams were going to hack on their satellites there on the floor. And they were going to travel to DEF CON to do this in their teams. When we pivoted to fully virtual, we then had to ship these satellites overseas, all around the world. And that during COVID, like when it had first hit, we had a huge logistical challenge on our hands. There was one team that got their satellite on the day before the competition. And the intention with this was to give them time to get familiar with the hardware and some of the software before the competition were to kick off. We decided for Hackasat 2 that we wouldn't ship the satellites until after the competition. So everyone got their satellites afterwards if they provided the white papers and the documents they needed to in order to claim those prizes. But there was a little logistical change from year 1 to year 2 where they were still all networked and you had to connect to that network, but you didn't get your physical satellite until afterwards. And year 2, we actually gave everyone a copy of a digital twin, which they had access to in advance, but not the physical hardware until afterwards.
Thank you, Delia. That's great. That's one thing I was going to ask too, the logistics, which points to you and your team for making that all come together. Because shipping a satellite one is not only amazing, that is such a great tagline for this, podcast. Shipping a satellite for competition, I mean, come on. And the fact that you can make it all run together. I did work closely with you and the team during Hackasat 1 and could not have been more really pleased to see how things turned out. Which is why, Steve, the floor is now yours. We know how great Hackasat 1 and 2 were. What do we have in store for 3?
So for Hackasat 3, we actually just launched our campaign April 8th, and our tagline is to learn space faster. And the idea behind that is because space is so complex, difficult, and knowing that we rely upon many facets of space for our daily lives, we're sort of pushing and nudging the communities to really take an interest in space and cyber, how they play together, how they're intertwined, but ultimately how to be safer and to secure these systems. And it's sort of what I said before with the commercial industrial base, if you will, or the new space industrial base that will be forming. There's a lot of experts out there that are going to be developing new products and new tools that we're going to be consumers of. So we want everyone to come up together and just take an interest in space and to learn it faster. Registration's open now at hackasat.com. And the top 8 teams will then move on to the finals. The finals are going to be in October. All the dates are on hackasat.com. And this year, we're going to focus more on the aspect of being space relevant and taking a look at a lot of the harder problems with respect to space. So it's not just enough to have some good cyber chops. Really have to understand the implications of a satellite in space and the multitude of things that can go wrong. Just take a look at the local news with any Starlink launch and what have you. There's a lot of different complexities up in outer space that don't exist here terrestrially. And we're trying to really expose those and the fact that space is hard. So we need to learn it faster. The Hackasat team will be at DEF CON this year, August 11th through 14, in the Aerospace Village with some things we can hand out, but more importantly, a few unique learning opportunities. So definitely check us out if you happen to be at DEF CON this year.
We'll be following along as the challenge unfolds.
Well, thanks for having us. We're happy to talk about it and answer any questions.
Yeah, thank you for the invite and the opportunity to discuss what we feel is a really important area of society.
Make sure to follow us on social media at Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And remember, stay curious.
Logging off.